every problem that we've done so far, we've rotated around a horizontal axis. Sometimes that's been the x-axis itself, sometimes it's been something below the region that we're revolving, sometimes it's been above the region that we're revolving, and so there's different nuances for each of those types of problems. But what happens if we are rotating a region around a vertical axis? So take a look at this problem. Find the volume of the solid obtained by rotating the region under the graph of y is equal to 9 minus x squared. X is running from 0 to 3. About the line, x is equal to minus 2. Not y is equal to minus 2, but x is equal to minus 2. Let's draw a picture to get a sense of what's going on. So y is equal to 9 minus x squared. X is running from 0 to 3. And so we are rotating this region over the axis over here. X is equal to minus 2. So we can still apply this same formula right here. The volume is going to be integral of pi times the integral between two endpoints of an outer radius squared minus inner radius squared. We just have to integrate with respect to y instead of integrating with respect to x. So we're going to be integrating from here to here, where this is going to be r out, and there is going to be r sub in. Okay, so what are these things in this case? The inner radius, well, here this is x is equal to 0 to x is equal to 2, so the inner radius is going to be 2. And then y is equal to 9 minus x squared. If we solve this for x in terms of y, we end up with x squared is equal to 9 minus y. X is equal to the square root of 9 minus y. It could be plus or minus here, but because we're over in this part of the graph, we want the positive square root. So this tells us that the outer radius, so the distance from here to here, is the square root of 9 minus y. But then once again, we're rotating around x equal to minus 2, so we have to account for that by adding 2 on there. So the inner radius is 2, the outer radius is square root of 9 minus y plus 2, and here is 0, and up here is 9. So our volume is pi times the integral from 0 to 9 of, it's going to be the outer radius, square root of 9 minus y plus 2, all of that squared minus the inner radius squared, dy. Okay, so when we expand out, when we do the simplification here, we end up with 9 minus y plus 4 times the square root of 9 minus y. And this is a pretty routine integration to do. It becomes pi times 9y minus 1/2 y squared minus 8/3 times 9 minus y to the 3/2 power. Plug in 0 to 9. To go from here to here, maybe the easiest way to see that is we're doing substitution with u is equal to 9 minus y, and du is equal to minus dy. If you have trouble seeing how we go from here to here, you can fill in the steps yourself. And when we plug in the numbers, you end up with 225 over 2 pi. So we can use this formula right here, even if we are revolving around, even if we're revolving around vertical axes, not just horizontal axes. Okay, so that finishes up this chapter, or I guess just this section. In the next section in this chapter, section 6.4, we're we're actually going to see a different approach, that there's another method. We don't have to use washers if we're revolving around vertical axes. There's a different way to handle it. So take a look at that when we get to section 6.4.